Well, hey Math 3 and Core Math 3 students, if you are like me and you're wondering how did mathematicians ever figure out how to make this law of cosines, this long formula, work out, then this is the video for you. Let's take a look at any non-right triangle. So let's call these different angles A, B, and C. And one thing that we're going to do is drop a helper line down, because this is a non-special, non-right triangle. So if I add a helper line down at a right angle to the base, this is something you spent time on in Math 2, creating these perpendicular lines from a straight edge and a compass, those kinds of things. So if we drop that down, now what that does is we still have side A intact, and we still have side B intact. The problem is side C, that was this long length between point A and point B, is now broken up into two pieces. So I'm going to call this left side D, and I'm going to call the right side E over here. And the angle of interest that we're taking a look at, we'll call that angle theta, or angle A here. So a couple things that we're going to do. And yeah, there's going to be some math and some algebra and things to follow along with this. So first off, I'm going to write a cosine ratio from this right triangle based on theta here. So cosine of theta. So with this, that would be the adjacent side D over the hypotenuse B. So D over B. And right after that, I'm going to solve it for D. So I'm going to multiply by B on both sides. So that's an algebra move or an algebra step. So I know that in place of D, I could actually have the expression B times the cosine of theta. All right, so what else? Okay, well, this length of E, yep, it's by itself, it's on its own, but I could also write E based on C and D, because put together, D plus E, right, if I add those two together, that is equal to the entire length of C. So if I just want E by itself, I'm going to subtract D off of both sides. So I could say E equals C minus D. E equals C minus D. Well, now that I already know that I could replace D with B times the cosine of theta, that's exactly what I'm going to do. So E could be written as C minus B times the cosine of theta. All right, so that was a substitution step. So now, what am I up to next? Let's actually write a sine ratio based on theta. So that's kind of interesting that in the law of cosines, we're actually going to see sine show up. So a sine ratio of theta up here, okay, so again, based on this right triangle on the left portion, that is going to be the opposite over the hypotenuse. Well, we didn't give a side letter for that height or that altitude, that extra line. So I'm going to call it M. I'm not sure what the M is for, but I'm going to call it M. For mu? Maybe. So sine of theta is M over B. M over B. And kind of like before, I'm going to solve for that top variable. I'm going to solve for M by multiplying by B on both sides here. So M, anytime I see that, could be replaced with B times the sine of theta. Okay, so where are we heading with all this, right? We have an expression for E, we have an expression for M. Well, what are we doing here? This is where I'm gonna kind of switch and look at this right triangle that we really haven't done anything with. And I'm going to write the Pythagorean equation with that. So if I were to do that, right, I've got my E leg, my M leg, and my A hypotenuse. So E squared plus M squared is equal to A squared. Okay, so that's why I kept these things on the board, because now we have something that we can replace E with, the equivalent expression of C minus B cosine theta. So that's going to take the place of E. So C minus B times the cosine of theta is squared plus the M expression, and that's where B sine of theta needs to show up, and that's also squared, and all of that is equal to this A squared. And we don't have anything for A, so we're just going to call it A squared. A squared. All right, so we used E, we used M, did some substitution here. What's next? Well, we've kind of reached the place where we've done as much substituting as we can do, and now instead we need to start simplifying. We need to actually go through and square these expressions. So in the case of this first one, C minus B cosine theta, we actually have to FOIL that because that's two binomials that we're multiplying together. So foiling, right? We're gonna take C times C, so that's C squared. But we're also going to end up taking, I should probably write it out for you. All right, so C times C, we got C squared. We're also gonna take C times a negative B cosine of theta plus another negative B cosine of theta times C. So that's two copies of it. So minus 2 B C's cosine of thetas, right? So that might kind of look familiar that, okay, we're starting to see part of the law of cosines appearing at this point. And then the last piece is to multiply those last terms. So we'd end up with a positive B squared cosine squared of theta. So plus B squared cosine squared of theta. And that's just from this first foiling. We haven't even done the other stuff that's being added on as well. So add that on. And then this expression squared, well, this one's different. It's not a binomial. It's a single term. So we can use the normal shortcut of squaring B and squaring that sine of theta that's in there. Okay, and all of that is still equal to a squared. So this is all one line equals a squared. Okay, what's next after that? Well, we need to start looking at maybe doing some rearranging or maybe even some factoring perhaps, because there are some terms here that have like pieces or like factors. So I'm gonna put those two together. So B squared cosine squared theta plus B squared sine squared theta. Then don't forget the rest of this, plus C squared minus 2B C cosine theta, and that's all equal to a squared. So it gets a little crunchy there, a little crunchy time. But yeah, these first terms in the expression both have this b squared, so I'm going to factor out that greatest common factor. So b squared times cosine squared plus sine squared plus the c squared minus 2bc cosine theta, that's all equal to a squared. Okay, so now comes something interesting that we haven't done yet in Math 3, and that is this expression of cosine squared plus sine squared. If you pick an angle, any angle you want, right? 20-degree angle, 80-degree angle, 200-degree angle, whatever angle you want. If you type in cosine of your given angle, 20 degrees or whatever you want to go with, and square it. Okay? So for us on the calculator, the square comes at the end. When written, right, it ends up between the cosine and the angle. Okay? And we add the sine of the same angle, 20 degrees, and square that. We're going to get a very specific answer. It's 1. It's just 1. If you were to do that same thing over and over and over with all kinds of different angles, it will always add up to 1. It is an identity. And so that entire thing can be removed and replaced with the number 1. So b squared times 1, or just b squared, plus c squared minus 2bc cosine of theta equals a squared. And of course, theta is our angle A, so this could be written as a squared equals b squared plus c squared, right? Most of that Pythagorean theorem, and then minus the 2bc cosine of angle A, right? That's exactly what our law of cosines is. So that's how they get from one place to the next when it comes to any triangle, whether it's right or non-right. This law of cosines will always work. So that's the proof. That's where it came from. Mathematicians don't just make things up. They make sure things are really true. So that's it. Good luck out there, and I'll see you in the next one.